Okay, we're going to do an example for an exponential equation that is a reflection over the x-axis from the parent function. So I'm going to draw this example in here. I'll be able to check to see if both of these points are part of my exponential function, and I'll show you that in a minute. But make sure anytime that you're drawing in an exponential function on this that both points work. Otherwise, you can just go between two of them and then do a new function to go between the next two. These two actually both work, and I'm going to show you why at the end. So in order to write out our exponential function, we need to recognize what type of transformations we have. So we have a translation to the left. I know that because my origin's way over here. We have translation to the left. And then I need to know, do I have a vertical shift? Do I have that vertical translation, or is it just going to be a reflection? So if I look here, my parent function has the parent point of 0, 1. Which means this is the side that I'm looking at for all of my lattice points. Any other points to the left here are not going to be lattice points. All my lattice points are on the right-hand side. So the piece that I'm going to actually be reflecting is this right-hand side. So I can reflect it down and then translate it over, or I can translate it over and then reflect it down. I'm going to choose to translate it first for no specific reason. You can do either. But let's translate it to the left and see what this looks like. So if I translate it to the left, I'm going to show my parent point on my actual piecewise function challenge map, which is 0, 1. I'm going to the left by 10. So what that's going to look like after I translate left is roughly something that looks like this. And it could keep going, but we're doing a restriction, so you want to make sure you write in your restrictions. But if I shift this to the left to -10, 1, all I've done is change my parent point from 0, 1 to -10, 1, because I moved to the left 10. And we're going to see, I want to keep that there because once I reflect over the x-axis, then I'm going to change this point is going to be -10, -1. I don't want to do any translations any vertical translations, because that +1 changes to a -1. That shows what I'm reflecting. That shows a reflection over the x-axis when your y becomes the opposite value. But before we get there, let's write out what we did when we translated. So first we went to the left 10. If we shift to the left, we know that that is adding to our x value, so +10. And then I reflected over the x-axis. There's my x. When I drew in those points to show my reflection, my x value is the one that stayed the same and my y value is the one that changed. So your x value should stay the same and your y value should become the opposite. So it's negative out in front because I now have a decreasing function. Okay, so that's where the negative goes if you reflect over the x-axis. If I reflect over y, that would be a different story. So now I need to find out my b value, which means I need to plug in a point that's not my starting point. My starting point here is -10, -1. The parent point was 0, 1. That's not the one I'm talking about right now. That parent point moved to the left, then got reflected, and this is my new starting point. So now I have 2 points that I'm going through. I need to make sure both of those are part of this equation that I'm going to write out. So I have to use one of them first and then check the other one after. So let's use the next one. This point is -9, -2. We're going to plug in the -2 for y and the -9 for x and solve. So I get -2 equals negative b to the first power. -9 plus 10 is 1. So that's just b to the first is just b. You can write it, you can leave it, either way. If negative b equals -2, well, that means b equals 2, so we can use that to write our equation. So we write y equals 2. I'm plugging it into this equation here because that shows both my translation and my reflection. This one only showed my translation, so we don't need that anymore. It'll be a -2, negative b value, and then x plus 10. All right, that is the b value I got when I plugged in -9 and -2. We need to use this last point to make sure that it's part of this function as well. So we're going to check that by plugging in -8 for x and -4 for y, because this point is -8, -4. When I do that, I get -2 to the 8 plus 10, which is 2. Remember your order of operations, this negative acts as multiplication to the base and its exponent, which means I have to do exponents first. So if I do exponents first, 2 squared is 4, and I'm multiplying by the negative out in front. Basically, we don't do -2 times -2 unless we have parentheses around this, and we don't. So I got -4 equals -4, so that works. That means both points are on that exponential function. So that's a good example for a reflection across the x-axis, writing the equation, finding the b value, and checking to make sure all points are part of that function.